This is the first of a series of videos where I'm going to go from an idea to a product that's available to buy. It's based on one of these puzzles you find online, a mathematical puzzle, and it's a physical model of that mathematical puzzle. It involves 3 water tanks, different shapes. You fill them up, you let the water run out. You have to decide which will empty first. I'm going to design it in CAD. I'm going to 3D print parts of it. I'm going to make other parts out of acrylic sheets, stick it all together, and then I'm going to test it in the sink, fill it with water to see if it behaves as I hope it does. That's the proof of concept, and that's what this video is about. So first, the CAD. This is how I designed the tank in Onshape. It needs 3 chambers, one with straight sides, one wider at the top, and the last one wide at the bottom. Each of these coloured shapes represents the water in the 3 chambers, which will flow out through an outlet that should be exactly the same for each. Around these chambers, we can now build up the wall, which is what will be 3D printed and have acrylic sheets glued to the front and back. My 3D printer has a build plate of around 250 by 250 millimeters, so I'm changing the size of the model to fill that. After a few more tweaks, I export the model into Bambu Studio, slice it, check it'll print cleanly, and then print it. Once it's printing, I create a version in Onshape so I can refer back to it easily later. In Onshape, I created a drawing and printed out. I'm going to use it to work out where to cut the acrylic sheet. This I do by just scoring with a blade and then snapping. I'm going to use superglue to put it together. The spray here contains an activator, which will make it set almost instantly. And yes, I should definitely be wearing gloves now. So that locks in almost straight away, and I just lift the corner here to check if it has, which it has. And now it's just a matter of repeating for the other side. It really is fantastic that this glue sets so fast. It makes producing proof of concepts like this very much easier. It almost looks professional. So this is a finished assembled tank. Now it's time to fill it with water and see if it leaks. I'm using masking tape just to seal up the holes. It's a bit crude, but it's a proof of concept, so this will do. Yeah, it started leaking. Not too much of a surprise. The 3D printer works by putting down layers of plastic, and they're not all perfectly sealed, so that's why it's dripping out. It could also be the masking tape. But it's not the bond between the 3D printed part and the acrylic sheet. That seems to be a good seal. It's just a proof of concept, so let's fill it up with water and see how it works anyway. If this was being used in a classroom, I'm sure the teacher would add some colour, so that's what I'm doing here. The tank's really dripping quite fast now, but it doesn't really matter. So let's fill the tanks to the top so they're all the same volume, and then we'll tear off the masking tape and see what happens to the water level. So the green one emptied first, which is what was expected. And what's nice is that it clearly finished first. It wasn't too much of a close call. So it's not entirely clear exactly when the tank is empty. It's a bit sort of fuzzy. I'm going to drill out the front here, just to let the outlet hole be lower than the floor of the tank. This seems to give a fairly clean flow of water. No need for anything fancy, I'll just seal it up with electrical tape. I'll speed this up so we get to the interesting bit sooner. I want it to be really clear when the tank is empty. That seems to work nicely. It was the design and assembly and then testing of this little model, and I think it worked pretty well. The water level dropped as it should. It was clear that this one finished first, even though it looked like it wasn't going to in the beginning. So the whole point behind this has worked. The proof of concept has worked. I liked parts of it. I didn't like others. Obviously, 3D printing isn't the way to go for this, but the acrylic sheets were great. So making it all out of acrylic, I think, will look really nice. I liked it when the spouts came out upwards, because then the height of the jets here corresponded to the height inside, and you could see it changing. So that's all part of the maths you can do behind it. But I also liked it when the hole was lower down, because when the water did finally get to the bottom, it disappeared into the hole. So it's very clear point in time when the tank was empty. So I think this bit here needs to be lower, but still pointing up. So I have to work out how to do that nicely. But yeah, slightly bigger. Maybe change the shape slightly. But for the most part, I think this was a real success. So proof of concept has worked. Now it's just to go on and make a better one.